Hey guys, welcome to today's class. Have fun.
My name is Amadi Solomon Chidebere, and I'll be considering a topic of probability. And in probability, I would like us to note that the probability of an event happening can be given a numerical value. So let's say that value is x, and probability is number of required outcomes over number of possible outcomes. Number of required outcome over number of possible outcomes. And let's take, for instance, that s is normally greater than or equal to 0 and then less than or equal to 1. And this can be seen in this way, whereby if we have x equal to 0, in probability this cannot happen. But when x is equal to 1, it is certain that an event will happen. But when an event is not happening, it is normally 1 minus x. You get to understand that better. Take, for instance, the probability that you pick A from the letter Babu is what? For you to pick A from the letter Babu, or let's say for instance to pick B from this word Babu, B appears how many times? 3 times. 1, 2, 3 over the total outcome is what? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 6 letters are here. So the probability that B will be picking at random here is what? Is 3 over 6, which is what? 1 over what? 1 over 2. I don't know if you understand. So this is the probability that it will happen, certain to happen. Then the probability that it will not happen is what? Is 1 minus 1 over 2. So this gives us what? 2 minus, this gives us what? 1 over 2 still. So if you check it, the probability that this will not happen is what? Is A, L and E, which is what? Which is also 3 over what? 6. That's what? That's equal to 1 over 2. So this is what this actually meant. So having gotten that, we'll move next to addition law. There are 2 laws in probability, the addition law and the product law. And addition law is applicable where we have what? Or either or. Whereas the product law is applicable where and is used in a sentence. So let's take, for instance, addition law. This is what it states, that events A, B, C are mutually exclusive. The probability of A, B or C happening is the sum of the individual probabilities. So in the event of A, B, C being mutually exclusive, the probability that A, B, C happen is the sum of what? Of the individual probabilities. Whereas when you come to product law, if events A, B, C, for this it is mutually what? Exclusive. Note the word mutually exclusive. That means they are what? They are dependent on each other. So you have to add them up. But when it is independent, when A, B, C are independent, I don't know if you understand. So the probability of them happening is what? Is the product of their individual possibilities. So I don't know if you understand. So we'll just look at some examples in the textbook here, then in subsequent time we'll just solve some of our WAEC questions. So a letter is chosen at random from the alphabet. We know our alphabet is 26. So find the probability that it is either in the word pyramid or in the word cone. So a letter is chosen in what? In the alphabet. So what's the probability that the word is either in? So note the word either. Note the word either, which is what? Which is addition law. So for the word being in pyramid you have how many? 1, 2, 3, 4, 5, 6, 7. 7 over what? The total letters in the alphabet, which is 26. It is either this plus what? It's either in this plus what? Or in what? In cone. And cone is what? 4 letters. So 4 over what? 26. So when you sum this, that gives you the probability that the letter is either in pyramid or in cone. But if a word is like used, if we put it this way, that the letter is in pyramid and the word is in pyramid and in produce, is in pyramid and in produce. So what will you use now? 1, 2, 3, 4, 5, 6, 7. So 7 over 26 times 1, 2, 3, 4, 5, 6, 7. 7 over what? 26. So that gives you what? The probability, which is what? This is 7 times 7 is what? 49 over 26. So when you calculate it, that gives you the probability that it is in this and what? And in this. So that's for the example. So let's take another example. So a card is chosen from a pack of 52 playing cards without replacement. A second card is chosen. What is the probability that they are both clubs? And there are 52 cards in a club. For some of you that play clubs, there are 52 cards in a club. So if a card is chosen from a pack without replacement, that gives us what? If a card, and in 52 cards in a card, we have 52 cards and 13 clubs. 13 are clubs in the cards. For some of us that play cards, there are 52 cards and 13 are what? Are clubs. So what a card is chosen from a pack of playing cards without replacement. So a second card is, what is the probability that they are both clubs? So the first probability that it is a club is 13 over what? 52. Then the next probability is what? Without replacement is now what? Having picked one club, we are now left with what? 12 clubs. So having been left with 12 clubs, we are now also left with how many cards? 51 cards. So this is after a club is being picked. So a second club being picked gives you what? 12 over what? 51. So the probability that two of the cards are clubs is what? Is being picked without replacement is 13 over 52 times 12 over 51, which gives you what? 1 over what? 17 if calculated. So another example I would like us to note, and this comes out in WAEC most often, is example 14. 10 cards are numbered. You have 10 cards, they are numbered 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So they are numbered 1 to 10, and then they are shuffled. 3 cards are chosen without replacement. You chose the first card, chose the second card, and chose the third card without replacement. So what's the probability that only one of the cards has an odd number on it, what's the probability that only one out of the 3 cards chosen without replacement, that one has an odd number on it? So I don't know if you understand. So if 3 cards are chosen from here, the first one is 2. The first one, the odd number 1, 3, 5, 7, and 9 is being chosen. But probably that only one of these cards has an odd number in it. So we have to use a tree diagram to actually get what we want. So you draw your tree diagram where you have your odd and your even. So since in the number we have odd and even, you have your odd and even. So the first one out of the odd and even, odd and even, we have our odd and even, odd and even, odd and even, odd and even. So this is the first selection, second selection, and third selection. So an odd was chosen in the first. Let's say the probability that odd was chosen, probability an even was chosen. After then the second one, an odd was chosen, an even was chosen. So this is odd, 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 even, odd, even, odd, odd, even, 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 odd, odd, and that goes on. Even, odd, even, 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 odd, and then even, even, even. So there are 3 ways of choosing an odd number, each with its own probability. So it is either this, just one. You see, what is the probability that only one of the cards has an odd number on it? So it is either odd, even, even, or odd, even, odd, even, even, odd, even, or even, even, odd. So the probability that is odd, even, even gives us what? Gives us odd. Probability of choosing an odd number first is what? We have how many odd number? 1, 2, 3, 4, 5. We have 5 odd number. Probability of choosing an odd number first is 5 over what? 5 over 10. I don't know if you understand. So if you now choose another number, it gives you what? 5, an even number now. It gives you 5. That's from this calculation. Probability of odd, even, 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 odd, even, 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 odd. 5 over 10. Then even is what? 5. There are 5 even numbers now. 5 over 9, but 9 cards. When the first odd number was chosen, there are 5 odd number. 1, 2, 3, 4, 5. So when an odd number, let's say for instance 3 was chosen, it now remain how many cards? 9 cards, but how many? But 10, but 5 even numbers. So 5 over 10 times 5 over 9. Now how many even number is remaining? Just 4. 4 over what? 8. So when we calculate this for this plus here, even for choosing even one even number is what? 5 over 10. Then times odd number is what? 5 over 9 times how many even number is remaining? 4. 4 over what? 8. Plus here we have 5 over 10 times 4 over 9 times 5 over what? Over 8. So when you calculate, this gives you 5 over 36. then plus this gives you 5/36, then this gives you what? 5/36. So the probability becomes what? When you calculate everything, that gives you what? 15/36. So when you calculate it, it gives you 5/what? 5/12. 3 times 5 is what? 15. 3 here will give you what? 12. So 5/12. So this is the probability that what? An odd number is chosen without replacement. So that's that for the examples. So we move next to solve some calculations, then before we solve some WAEC calculations. So we're going to be making justification to some of the questions here. We're going to be making some justification to 19AB and 20AB. So in 19A, let's say in a game, a fair die is rolled once and 2 unbiased coins are tossed once. So in a fair die, we have how many faces? We have 6 faces. So the probability of obtaining a 3 is what? Out from 1, 2, 3, 4, 5, 6. The probability of obtaining a 3 at one row is what? Is 1/what? 6. Whereas in an unbiased coin, when these 2 are being rolled, is either we have a head and a head, or we have a head and a tail, or we have a tail and a head, or we have what? A tail and a tail. So the probability of having a tail is this and this. This is tail and tail, one tail. So 1/2 times 1/2, 1/2 times 1/2. So this 1/4, this will give you 1/what? 4. So, but here we are being asked what is the probability of obtaining a 3 and a tail. So the probability of obtaining a 3 is 1/6. The probability of obtaining a tail here is 1/4 plus 1/4, which will give us what? 2/what? 2/4. Is that not so? So having a 3 and a, note the word and is product law. So this will give us multiplication bracket what? 2/what? 4. So that gives us what? 1/what? Over 12. So for 19B, a box contains 10 marbles, 7 of which are black and 3 are red. 2 marbles are drawn one after the other without replacement. So find the probability of getting a red, then a black marble. So a box contains how many? 10 marbles. So 7 are what? 7 are black, and then 3 are red. So if 2 marbles are drawn without replacement, the probability of having a red is what? Is 3/10. Then the probability of having a black marble without replacement, after you've drawn 1 red, you now have 9 what? You now have 7 plus 2, which is 9. We now have 9 marbles, 7 black and what? And 2 red. So the probability of drawing a black will now be what? Will now be 7/what? Over 9. So this gives us what? 3 here 1, 3 here 3. This gives us 7/what? 7/30. So the probability of having 2 black marbles, so when you draw 1 black here, it will give you 7/10 times you draw another black, it will now become 6 black, 3 red, 6/what? Over 9. So this gives us what? 3 here is 3, 3 here is 2, 3 here is 3. So 3 here 1, 3 here 5. So that gives us what? 7/what? 15. So this is the probability of having 2 black what? Marbles. So 2 black marbles. This one probability of having what? 1 red and 1 black. So you get. So if you look at number 20, you saw for number 20, number 20A, the probability that a candidate passes an examination is what? Is 1 over 5. So the probability that a candidate passes an examination is what? For him passing an examination is 1 over what? Over 5. So if probability of passing an examination is 1 over 5, the probability of not passing an examination will be what? 4 over 5. How do we get it? 1, we told us 1 minus what? Minus our possibility. So if you remember what we did, so if this is probability of passing an examination 1 over 5, probability of not passing an examination will be 1 minus 1 over 5, which gives us 4 over 5. So they say find the probability that if 2 candidates are selected at random, only 1 passes the examination. So if 2 candidates are what? If 2 candidates are selected at random, only 1 passes the what? The examination. So the probability that a candidate passing the examination is 1 over 5. Find the probability that if 2 candidates are selected at random, only 1 passes the examination. So this will be what? Let's say for instance, it's either we have, if 2 candidates are selected, it's either we have a pass and a pass, a pass and a fail, or a fail and a pass, and then a fail and a fail. Is that not so? This is the possibility for 2 candidates being selected at random. So for 2 candidates are selected, if only 1 passes, so we have pass and fail, fail and pass. So it's either the first person selected pass and the second person fail, or the first person selected fails and the second person pass. So the probability of the first person passing and the other one failing is what? We have 4 over 5 for passing, and then we have what? 1 over 5 for what? For failing. So plus this, which is what? For failing is 1 over 5 times 4 over what? Over 5. So if we calculate for this, it will give us what? This is 4 over 25 plus 4 over what? 25. That gives us what? 8 over what? Over 25. So the second one says 3 candidates are selected at random or pass the examination. So for all passing the examination, we have P and P, which is 1 over 5 times 1 over 5 times 1 over 5. You say 3 candidates selected at random, so 3 of them pass, so which gives us what? 1 over what? 125. So this is this. So we also like to also solve some wire equations. So let's get to solve some wire equation. So I got a wire equation from 2012, part 1. Part 1, 2012 wire equation, part 1. If you check 4a of that wire equation, the equation goes thus: a box contains 40 identical discs which are either red or white. If the probability of picking a red disc is 1 over 4, calculate the number of white discs. So a box contains 40 identical discs which are either red or white. So if the probability of picking a red disc, so here, the probability of picking a red disc is what? Is 1/4. So they say find the what? Calculate the number of white discs. So let's say X is the number of red disc. So X over the total number of discs will give us the probability. So if there are S number of discs, so for you to get, if there are X red number of discs and Y white number of discs, the probability of having red is what? X over what? 40. Is that also probability of having red is X over 40? So X over 40 gave us what? 1/4. So from here to get our X to now be X equals to what? 40/4, which is equals to what? So 10. So we have 10 red discs. So if we have 10 red discs, our white discs will now be what? 40 minus 10, which gives us what? 30 white what? 30 white discs. So our B part says red discs. So calculate the number of red discs that should be added such that the probability of picking a red disc will be what? Will be 1/3. So for the probability of picking a red disc to be 1/3, which means a given number of red discs has to be added to this. So if 10/40 was the initial number of red, which means for there to be 1/3 as our red disc, that means X has to be added here. X has to be added here to give us 1/3. Is that not so? So if X number of this was added, so what do we now have here? We now have what? 3 in bracket 10 plus X, which is equals to 40 plus X. That also. So that gives us what? That gives us, if you open the bracket, it gives us 30 plus 3x equals to what? 40 plus x. So like terms, so 3x minus x equals to 40 minus 30. So this gives us what? 2x equals to what? Equals to 10. So x is equals to what? 10/2, which is what? X is equals to what? Equals to 5. So 5 number. So from this, they say calculate the number of red discs that should be added. So 5 number of red discs will be added such that the probability of picking a red disc will be what? 1/3. So this is how to calculate that. Thank you. I think we'll come to the end of probability. I believe with this you'll be able to solve some questions. So WAEC will come out with tricky questions, but take note of some of the laws that's been given to us down here. And if we take note of that, I promise us that we are going to be having an excellent calculations in probability. So my name remains Amadi Solomon Chidebere. Thank you.
I hope the class was interesting. If you have questions, please drop them in the comment section or send us an email. We will love to help you further. See you in the next class.